So we were working with radicals last week, and we talked about reducing our radicals, how to go back and forth from exponential form to radical form. We talked about adding and subtracting with our radicals. So the last piece, and I think on that handout I told you you could have done 1 through 17, now I remember, and it's just up through like 25 or so that these last questions cover. So we are going to talk about what's called rationalizing the denominator. What that means is if you have a radical, you are not allowed to leave that radical in the denominator. So if I am looking at this problem, I have to move that radical 3 off the bottom. How could I do that? Now, if you multiply the top by radical 3, you also multiply the bottom. The rule is whatever you do on top, you have to do on the bottom so you don't change your problem. So on the top, 1 times radical 3, anything times 1 is just itself. On the bottom, if you're multiplying radicals, you can multiply the numbers underneath. So you get the square root of 3 times 3, which is 9. And what is the square root of 9? So our answer is radical 3 over 3. Now, some of you may be able to skip writing this middle step. If you know that radical 3 times radical 3 is just going to be a plain 3, that's fine. You can jump there. But I would appreciate you showing me what you're multiplying by on the top and bottom for now. Is that one all right? You could multiply by 4 radical 2 on top and bottom, but that is actually not necessary. This is one term. The only part I really have to move is the radical. So all I really have to multiply by is that radical. Now on the top, when you take 5 times radical 2, the rule is you can multiply numbers outside radicals together and you can multiply the numbers inside the radicals together. So I can't actually multiply the 5 and the 2, it's just 5 radical 2 for my answer. On the bottom, 4 radical 2 times radical 2. What's that become? So 5 radical 2, there's nothing I can do there. On the bottom, what is the square root of 4? 2. So this is like 4 times 2, which would be 8. And that's in my book. Now, yes?
If the 5 is like a 4,
then you reduce. Yes. So if you got like 4 radical 2 over 8. I cannot reduce the 2 and the 8 because the 2 is under the radical. But the 4 and 8 are both outside the radicals, so you could divide them by 4 and get radical 2 over 2. So do write it in lowest terms. Other questions? Okay, let's do a hard one. Anybody remember? Yes. It's called the conjugate. If you have 2 terms on the bottom, so because if there's an addition or a subtraction sign, you have to multiply by the conjugate, which is the exact same thing, except you change the sign in the middle. And we will do that on the top and the bottom. the top, we are going to have to distribute. Square root of 2 times the square root of 3, square root of 6, plus square root of 2 times the square root of 2, square root of 4. On the bottom, how am I going to multiply these? Boy. Square root of 3 times the square root of 3, the square root of 9, plus the square root of 6, minus the square root of 6, minus the square root of 4. I lost it.
Why do you add and then parentheses, same as they and
Why did I put those in?
Yes.
Basically just so it's a note to myself so I make sure I'm distributing all the way. I tend to do that anytime it's more than one term. So if there's a plus or minus, put parentheses around them so you make sure you're distributing everything. And that's the same reason I went back and added them here, just so I realized this whole thing times that whole thing I have to pull in.
Okay.
Other questions? Now, what do you notice about the bottom? Yeah. Well, we can cancel out these, positive square root of 6 and negative square root of 6, cancel. And that's always true because they're conjugates. Okay, let's simplify what we can. I cannot reduce the square root of 6. What is the square root of 4? On the bottom, the square root of 9, 3, minus the square root of 4, which is 2. Okay, if you combine like terms, 3 minus 2 is 1. Is it necessary to write this over 1? No, you could just write the square root of 6 plus 2 for your final answer. Yes, ma'am.
Before you, could you take the radical 6 and the radical 4 and put them together since they're like terms?
You cannot. Remember when we're adding radicals, they're only like terms if it's the same thing under the radical. So if it was like radical 6 plus radical 6, you could make it 2 radical 6. But since these numbers are different, you can't add them.
But you can multiply them?
Yes.
what is it, H-L?
If
Radical 12, I mean,
you actually think about when you do x squared plus x squared, you get 2x squared. So it's just adding the numbers in the front. So it becomes a 2 radical 6. You don't actually add the numbers under the radical. Other questions? Let's do another one of those. They're a little bit up there. Whoops. So what do I need to multiply by? If you only multiply by the square root of 2, then if you look at the bottom, since this is 2 terms, you would have to distribute. And you would get 5 square root of 2 minus the square root of 4. Does that actually get rid of my radical? This one would turn into a 2, but all I did was move the issue to the other term. So if you have more than one term in the denominator, even if they don't both have radicals, you still have to do the conjugate. So this would be 5 plus the square root of 2. Alright, I put parentheses around them because it's more than one term. I want to make sure we are distributing. So on the top, 3 times 5, 15. 3 times the square root of 2, it's just 3 radical 2. What do you need to do on the bottom? FOIL. 5 times 5 would be 25. 5 times the square root of 2 is 5 square root of 2. Negative radical 2 times 5 is negative 5 radical 2. And you might know those are going to cancel, and if you don't write them, that's okay. Because they're conjugates, they will always drop out. Negative radical 2 times positive radical 2 is negative radical 2. Okay, so simplifying. On the top, these do not reduce. They are not like terms, so we can't add them together. Bottom, those drop. The square root of 4 is 2, so really I have 25 minus 2, which is 23. Okay, in order to be able to reduce at this point, whatever is on the denominator would have to be able to divide both of those numbers. So this one I can't do anything. That is my final answer. Questions on that one? Do you guys remember doing those in Algebra 2? Remember in Algebra 2 we also did some that weren't just square roots. We worked with cube roots and fourth roots and fifth roots, so we should still be able to do all those, right? So, on this one, don't write this down yet. If all I did was multiply by the cube root of 3 on top and bottom, I would get 4 cube root of 3 on top, and on the bottom I would have the cube root of 9. Can you do the cube root of 9? No. So we have to think about it differently. Okay, there are a couple options. We could think of this as I have 1 3. In order to cancel my radical, you need 3 of them. So how many more do I need? 2. And so I could say, all right, I'm going to multiply by the cube root of 3 squared on top and bottom. I'm going to show you another way to do it in a second as well. So when I multiply this, the 4 wasn't under the radical, it stays outside. I have the cube root. What is 3 squared? 9. On the bottom, if you're multiplying those, you add your exponents. You could write it as 3 to the third. You could go ahead and make it a 27 if you wanted. Either way. What's the cube root of 3 to the third? Or the cube root of 27? 3. It's like saying you have 3 3s, so how many groups of 3 can you make? 1. Okay. That's one way of thinking about it. I'm going to do a second one, and I'm going to show you another way of thinking about it. So you can kind of pick what you like. On this one, maybe. What this means is the 4th root of 3 over the 4th root of 5. So one way of thinking about it would be, I have 1 5, how many more do we need? We need 4 total, so if we have 1, we need 3 more. The other option would be, in algebra 2 we talked about things to the 4th power. Like 2 to the 4th is 16. 3 to the 4th is 81. 4 to the 4th is 256. 5 to the 4th is 625. And we had to figure out, okay, what could I take 5 times to turn it into one of these numbers? One of these perfect 4th powers. We did it a lot with variables in algebra 2, maybe not as much with the numbers themselves. So if you think, can you do 16 divided by 5? No, 81, 256, 625, and that is 125. So you could multiply by the 4th root of 125 on top of that. Since you guys are looking at me like you don't remember ever doing that, I'm going to do it the same way I did the previous problem and be consistent. Okay. This is a 5 to the 1st. Because it's a 4th power, I need 4 of them. So you need 3 more 5s. So on the top, they are both under the radical, so take 3 times 5 to the 3rd. You can use your calculator. What does that give you? On the bottom, you can multiply it out. 5 times 5 to the 3rd, you could write it as 5 to the 4th. You have the 4th root of 5 to the 4th. This is just like 5 to the 4 divided by 4 power, which is 5. And that is our final answer.
Okay, so whenever you have like your outsides, like 4 on each side, so whenever like either one of those is gonna be here, you just go for 3 on all.
What? If this were like, say I did the 4th root of 3 over the 4th root of, if this were a 5 squared. I have 2 5s, I need 4 total, so you would need 2 more 5s.
You always worry about the bottom.
Yes, we don't care about a radical on the top, just the bottom. All right. Questions there? We are going to do a few more problems. First, I'm going to put one up here I would like for you guys to try. You can do both of these. I just want you to multiply them. So multiplying with radicals. Okay. So if we FOIL, we get the square root of 121 minus the square root. What was 17 times 11? Plus the square root of 187, which you could have just not even done those two since they're conjugates. You know they're going to cancel out. So you get 11 minus 17, which is negative 6. Is that one okay? Second one, if we FOIL, 5 times 3, we get 15. 5 times negative radical 2, since the 5 is not under the radical, it just stays outside. Radical 32 times 3 would be 3 radical 32. Minus, since they're both under the radical, we multiply them. Minus radical 64. Okay, let's make sure we got this one correct. From here, we have 15 minus 5 radical 2. Okay, think back to last week. What do you know about the radical 32? Break it down into what? Square root of 16 is 4 times 3. And what is the square root of 64? So now 15 and negative 8 would give me a 7. Negative 5 radical 2 plus 12 radical 2 would be 7 radical 2. So we get 7 plus 7 radical 2. So you always need to break down any radicals that reduce. Okay. So we try a couple more challenging problems and then we'll finish.
Can you do like another one like maybe there?
Yes, I can. I'll add that on here. Alright, so this first one. What do you have to add or subtract fractions? Common denominator. But we also know we can't have a radical on the bottom, right? So let's start there. Can I reduce the square root of 12 at all? We could break that into a 4 and a 3. Square root of 4 is, so I get 2 over 2 radical 3. Minus, what do we break 27 into? Square root of 9 is 3. Okay. What do you want to do next? We can't because we have a 2 radical 3 and a 3 radical.
So the whole equation is the same.
Yes, the whole thing is the same. So, we have a couple issues. We have to get the radical off the bottom, right? And we have to put these things together. Which one do you want to do first? No, go ahead. What were you going to say? Okay, let's do that. So you're saying take top and bottom times radical 3 on both.
Yeah, on both.
So this would give me 2 radical 3 over, this would be 2 times the square root of 9, which is 6. Am I going to lose anybody if I go ahead and do that? Minus, if I take this one times radical 3, get radical 3 over, this would be 3 times the square root of 9, so 3 times 3, which is 9. Okay. Could I reduce 2 radical 3 over 6?
Yes.
What would that be? Radical 3 over 3 if you just divide by 2. Okay, now if I need a common denominator, what are we going to do? Multiply this one by what? 3. So I
can do it to each side.
You can do it to each side if it's an equal sign, or you can do it to top and bottom if it's a fraction. So I get 3 radical 3 over 9 minus radical 3 over 9. Denominator is the same. 3 radical 3 minus 1 radical 3 would be 2 radical. Okay, there were a lot of different paths we could have taken on that problem.
I thought you could combine those because they don't have the same front number.
It's the radical number. When you combine them, you add or subtract the front numbers. It's the thing under the denominator that has to be the same. Now, earlier I couldn't combine them because if you want to add or subtract fractions, the denominator has to be completely the same. Yes, when we're looking at the denominator, it has to be exactly the same. But to add or subtract, it's the radical that has to be the same. Okay, that one really combines a lot of the skills we've done in this section. Breaking down radicals, adding fractions, getting our common denominator. So this one had a lot wrapped into one problem there. Okay. Let's do do this one. So you had a question I gave you. Yeah, I'm making up a problem here.
Okay.
Add it on the bottom there. So if I asked you to multiply this, what would we need to do here? What? Okay. So 5 times 2 would give us a 10. When you do 5 times the radical 3, can you actually make it like a radical 15 or anything? No, because the 5 is not under a radical. So you just leave that as 5 radical 3. Okay. This would be negative 2 radical 8 minus radical 24. Alright, so looking at this, can't do anything to 10, I can't do anything to 5 radical 3. What about radical 8? How would you break that down? Square root of 4 is 2 times this 2 would give me negative 4 radical 2. 24, how do I break that down? Square root of 4 is 2 radical 6. Do I have any like terms? No. So I'm done. That's all we can do there.